Good morning, I'm Cody Hendrickson, and today we're going to be taking a look at what we can do to actually do a Java database connection on the code side. Again, I want to start with that vocabulary. This is the stuff you want to make sure you're looking for as we go through this video, as well as some of the others we're working on, so you can make sure you understand the things we're specifically looking for. Just a quick review: the terms connection, connection string, driver, metadata, prepared statement, query, result set, SQL or squirrel injection, and squirrel exception are things you definitely want to be looking through as we work through this. So again, keep that vocabulary in mind as we go through this, because we'll be coming back and using those terms as we go through the entire process. Thanks again. We're going to go ahead and start off with the code side right here. As you can see, I'm inside my app controller, the one that's just in charge of starting the regular application, doing all the back and forth. If we had a model package, this would be able to be sending information back and forth to that. And it has, of course, our start method. As you can see right here, we have our app controller. It has the constructor. It initializes the database controller, part of the controller family. Then it initializes the GUI that goes along with it, as well as the pop-up for that. Inside our start method, as you can see, we call the data controller's instance. We call it checkConnection, making sure we're able to load that up. We'll go ahead and take a look at that. But before we do so, let's go ahead and take a look at the actual project properties really fast. So we have inside our database example right here. If you can bring this over here and take a look, you'll see I have my MariaDB-java-client-2.6.0.jar file. That's the driver library. That's the file that allows the connection to happen, and it has all the stuff that makes it so we're able to connect to a MariaDB database inside this. And again, to make sure we can add that to our project, if we go up to our project right here, we right-click on it, we go over to our build path, and we'll go ahead and do configure build path so we can see all the settings for that right here. And I go over here onto my library section. You can see that I've got a library added right here. And all I have to do so is I just go ahead and click on the Add Library button, or Add Jar is what I did for that. And I click on inside my project, and I would go through and find that project inside there. Or you can go to the Add Library. And since it's already inside there, I can just add it. I'm going to go ahead and I'll remove it here really fast. We can see how that process is. So I'm going to go ahead and remove that really quick. So I'm going to go ahead and add the jar for this. So I click on the Add Jar. I'm going to click on the triangle for this. And as you can see, it's listed right inside my project because I just dragged it inside my project itself, so it's part of the file there. I click on it and I say OK. It's now part of the actual library for that. It's something that's going to be in the build path and the execution path for this project. Again, since we're doing this on a project level, we have it right there. So we'll go ahead and apply and close. And that allows me to make access to all the components that go along with this. So as you can see, it's right here inside my library for that, so it's part of the actual project. We're good to go. You can see inside my controller, I have my app controller, the database controller, and my runner. Runner's pretty basic, don't need to review that at all. And then some of you will look at that in other videos when we talk about how we can actually talk to this on a GUI side as well. We'll go from there. Back to the code. So we're right inside here. We're inside our app controller. You can see we have that first, we initialize our controller and we call the checkConnection. So that's what we do to start off with that. Let's go ahead and actually look at the code that goes along with this and then go from there. As you can see, we have our database controller class out. All the methods and stuff are collapsed down, so we don't have to worry about looking at them right now. But you can see it's a fairly involved class. Now, this is just for basic database access. If we're doing more advanced stuff, we have to do a little bit more for that. But we have the basic structure we have that we can use right here. Again, we have our package statement that tells us where the project itself is located. In our import section, the first one we have is import data.view.popup, because we'll be using a popup to handle some information within the project. We have in our next import java.sql.asterisk. I import everything from the squirrel library. There's no reason not to. We're using so much inside even just a basic project that rather than spelling every single thing we're using out of that, I just do .asterisk to get all of it. Finally, the last import is for vector. I've talked about vector in my advanced data structures class already, but remember a vector is like an array list but a little bit extra behind it. And so it's a great thing to use, especially when we're talking about using structures that talk from a dynamic structure to a fixed structure. It's a great way of getting information back and forth because of the thread safety that runs at the behind the scenes sign of that vector. In our database controller's data member section, we have the following data members. We have a reference to our pop-up class because we're going to have to interact with that if there's any problems. We have our connection. Again, there's that vocab word coming back to the data connection. Again, boring names make my life better. We have a string array called invalid, a vector of type string called current headers, and a vector of string. That's right, it's like a 2D vector. Well, it really is, but it could both resizable this way and this way, but in reality, it's only resizable this way. And we'll talk about that more as we go through, and that's called current data. Let's take a look first at our constructor. As always, in our constructor, we initialize the data members we have to worry about. So invalid, I'm initializing with a new string array. Now, we talked about this in the previous lecture. We're making sure we're going to prevent any inappropriate use of our project from talking to a database, because our project, by definition, is designed to access any database. And so to do so, I'm explicitly saying that certain commands will not be able to be ran inside this program. As you can see right here, I'm not allowing drop, truncate, or 1 = 1, grant, or revoke. And again, those are so I can prevent any structural damage or any data damage to my actual database. We sent current data and current headers both to be null. Normally we don't want to have a null variable, but because those are dynamic values will be recreated every time we need to use them, I'm initializing them to null at first because I don't want to actually use anything in them until they're ready. And finally, now that I've initialized all my model data or my component stuff that goes to the controller, I initialize my pop-up window so I can get access to it and use pop-ups as necessary. The first method we have is the checkConnection method. The checkConnection method is how we're going to be able to actually grab information from the user to make a proper connection to the database. So we have, as you can see right here, a bunch of different questions we're asking. What is the user? Who is the user? What is your password? What's the database address? What's the database's name? Hey, those are the same questions we talked about in the previous lecture. We need to ask those questions so we can actually talk to the database itself. We store all those values as strings, and then we use the magic power of string concatenation to put that together in a single string in the URL format of a connection string. As you can see right here, JDBC : MariaDB : whack whack, then the address, then the database name, and then we interrupt the database URL path with the $user equals user and the question mark and the ampersand password equals pass. So I can build that password from there. Now please notice that on my string pass equals view.secureInput, I'm explicitly using security. Again, like we talked about in previous videos, security and privacy inside a project needs to be strict. Security and privacy inside projects, even on the basic beginning level, needs to be something we address explicitly. We can't keep having security pushed off until you're later or working on the project. You want to start with security, at least at the very basic level, on even early projects. So that's why we have that using the secure input method. Check a look at the video on how to use secure input with pop-ups to verify how that works. Once we've gone through and we've built that connection string, the next step is we have to actually try and see if we can work it. Now again, with everything we're doing inside database land, almost every single command can throw an exception, so everything basically gets wrapped up in a try-catch block. In this case, we're going to say the data connection, that connection object, the way we talk to the database, we're going to see if we can initialize that connection by using the driver manager static method getConnection. We pass it the connection string, which hopefully has all the correct information from the user that they just typed into the pop-up windows, and then it will hopefully correctly execute. If it doesn't, it'll throw the exception, and boom, we're able to move on. We aren't even giving a notification that we're connected properly. I guess I could add another pop-up window, say, hey, you're correctly connected. But as long as it doesn't throw an exception, we're good to go, we move on. So that's the basic start. So we've got that going right there. We'll go ahead and collapse these two down. The next thing we want to take a look at is the parseStatement method. The parseStatement is, again, how I'm handling that array of string invalid, making sure they don't use anything inappropriate when we're talking to the project, because, again, we want to have secure project running. So the parseStatement method is a public Boolean method. I could use this so it could be accessed externally if I needed to, but it's almost only used internally. But that says true or false whether you can actually run that statement. And so for every string bad word inside invalid, that array of strings we don't want to see running inside our project, if that statement contains, by lowercase formatting, so we don't have to worry about casing on there, if that bad word is anywhere in that string, then we're not going to run it. We're going to immediately return at this point, return false right there. And it has to say a quick little message, hey, this statement is not going to be executed because it contains, and then the bad word. We do not want to have any of the inappropriate content being run by our application, and so I'm explicitly having it handled right here immediately. So before we run any single statement, this parseStatement method gets called over and over again to make sure we don't have any chance of destroying someone's data or hurting our own structure. So that's what we're doing with that. The disconnect method is really quite basic. Because we don't know exactly when we're going to be leaving the database, we just have the try on the DatabaseConnection.close, and then as it crashes, which it really shouldn't, we can catch the exception and handle it with the handleException method. So again, just when it's time to actually leave, we call the disconnect method, and we're good to go, we're ready to leave. And a great thing to do. As I've mentioned, almost every single thing we're working with inside database land has the capability of handling almost everything we're doing inside database land has the capability of throwing exceptions. So we have to have a way of dealing with that inside our project to prevent it from crashing all the time. The way we're going to do that is we're going to have a quick little method that can process those exceptions without stopping the execution of the program. As you can see, I'm using my pop-up class view to do the display message, and I have 3 different messages right here. I'm not using just one message and with all the information in one giant, huge pop-up. I'd rather have it with 3 different things so you can pause, take a look at it, and use that to do some troubleshooting outside of the project and figure out what's going on. So we have 3 different things we're looking at. The first one is the error code that the SQL server sends us. So SQL error codes actually can be looked up on the internet and found out, oh, this is what that is happening right there. So it's a great way we can find it and troubleshoot the error. Again, you can go put that SQL error and then the number, boom, you can find out what's going on. The next one says what's going on inside the server. The SQL server state gives us what's happening in the server. What's going on right now? What does the server say about what's the problem, what's happening with that? And so that's what we do with that next one. And finally, the last message is the actual error message that Java has about this. What is going on the Java side of this? We can see 3 different levels of information every time we have a crash inside our app, but our app doesn't crash itself. We can handle it and move on. And so that's the basic structure for there. Go ahead and collapse that out as well. Now, as we talked about in the previous video, we've got a couple other pieces of information we have to worry about, and we're going to go over those really quickly. We have a couple public methods, but the rest of the methods are private, besides the two getters right here. The two getters, really basic. It's just a return vector of string for headers and a return vector of vectors for string for current data. Those aren't really big. We don't have to worry about those. So let's go take a look at the two public methods. They handle the two different ways of handling information inside a database. Again, we have our simple query where it can do an update for individual rows using either an insert, update, or delete command. And then we have our query one, the select one, which gives us lots of information. We'll take a look at the first one, the public int one, for handleDMLStatement. So for handling the CUD of a CRUD. So for handling the CUD of a CRUD method, we have to have, the first thing is, of course, we have our parameter for the statement, the actual statement we're going to be executing for that. And again, like I talked about, we use the parseStatement method check to see if it's okay to actually run that statement. If that returns true, then we can go ahead, leave out of there, and go inside the try block, because again, everything happens in a try block in here. The first thing we're going to do is we're going to create a prepared statement. Again, a prepared statement is a way we can actually run queries on a run queries on a database using the Java programming language. And that prepared statement has a whole bunch of power and features in here. Right now, like I said, it's just a quick demo version. If you wanted to add more to that, you can add methods to actually update things based on markers like question marks. You can replace different values as you go through, say, for example, a data structure. Really cool stuff. But we use the data connection again, and we call the prepare statement method, which creates the actual execution statement that can be run on the server. We then take that prepared statement and we say execute update. The execute update value returns an int value, aka the number of rows that were affected by running that statement. This can be anywhere from 0 to n, depending on what kind of statement we're doing. Then, because this is a simple DML statement, we want to make sure we close that statement and have it finish off, because we don't want to leave the connection to the database open for anything like a man-in-the-middle type of attack or any other problems that could potentially happen. And again, because all three of those statements right there could potentially result in a crash, we have to have that caught within a try-catch statement, and we pass it this handleException method, taking it the error. Once that goes through, we return the result of how numbers were affected. We can access that and use that later on. Now, the next one we have is the public method, is the processQuery. And that's if we're going to do a more complex select type query. Now, as you can see right here, the processQuery method is a little bit shorter. It doesn't have as much work to it. So the first thing it's going to try and do is it's going to try ResultSet results equals handleQuery query. So again, we're using the try with resources, the new, stronger feature of the try-catch statement that allows us to automatically close the query when it's time to. Great thing to do. So we're going to try and see if that works. Then we check to say if that handleQuery method is okay, if it's valid. We're going to say if results not equal null, then we're going to grab the titles and process the result set from that result. And then it'll catch the exceptions. Now, as you can see, we're using a lot of different method queries to call information in that. So let's go ahead and take a look and see what happens inside the bean. What happens behind the scenes for that. So the first one we have to go is look at the handleQuery, which takes that string query and passes it on to here. Inside the handleQuery method, as you can see right here, the first thing we do is we set ResultSet to null, because again, we don't want to have any wrong information available for this. So we create that value and assign it a value so we can return it immediately, but then we go through and check to see if it works. Again, we start off with the parse statement passing a query, making sure that the query we're running is totally okay. We don't want to throw a bad thing in there. Again, security and safety of our data and our users is important. We want to maintain that. Again, we wrap everything inside a try-catch block, just like always. And again, just like inside the handleDMLStatement method, all three of the lines inside the handleQuery method could potentially throw an exception. The first line is exactly the same. Prepared statement current equals data connection.prepare statement passing the query. It's the exact same structure, because when you're preparing a statement, whether it's for DML or a select query, it's all the same. It doesn't matter. However, what's different is we set results equal to current.execute query. So when we're executing a query, we get back a result set, a dynamic object that isn't finished. Okay? So that's where it also is different right here on that next line where it says current.closeOnCompletion. We're not done with the result set. So we don't want to close it immediately. We have to wait until it's time to close it. And so that gives us a result set, but the result set's not ready to close yet. That's something that we have to make sure we keep in mind. We're not done yet. So we can then go back over to processQuery. We say if that result's not equal to null, we're going to go look inside that. We're going to take results and send it to getTitles and say that same variable and also pass it to processResultSet. So let's go look at getTitles first. The getTitles method, we do that first because we want to get the metadata out of the information and assign that value to what we're working with. Now, the first thing we do is create a vector of type string called headers. It's a new vector of string, just looks like a new array list type of structure. Again, we want to check to make sure we're not working with null because we don't cause a null pointer exception. That's another error to worry about. We then wrap that inside a try-catch block just like normal. However, inside here, we're going to say ResultSet metadata, naming it table info, what's about that. It's talking about what's inside the actual data itself. And so we'll call the data.getMetadata method. We then are going to iterate over that metadata. So for index is 0, index is less than table info.getColumnCount, index plus plus. And we're going to say headers.add. and we're going to put a string inside there, tableinfo.getColumnName index plus 1. Because remember, when we're talking in database land, the indices inside databases always start at 1, never 0. Remember that again? Database indices always start at 1. And so we have to make sure we always prevent an oboe in there by making sure if we start our indexes ourselves, like we normally do with 0, we add 1 to it so we don't cause it to throw an index out of bounds or a number found exception. So we have that right there. We process that information, and we then return that array vector of string back into our data member current header, so I can have the headers for that current query. I then need to actually get the data for that query, and that's where I say current data equals processResultSet passing it results. So let's go look at this private method right here and go to it. As you can see in processResultSets, again, I take the result set as a parameter. I'm keeping this private because I don't want to ever have that result set outside and used by anyone else. This is only internally this one file that we were working with. I create a new vector that's a vector of type string called table results, and I initialize that appropriately. I then put a try block in there, and I want to check to make sure, again, that data is not null, because, again, I can't actually look inside something if it's null, so I have to make sure it's good to go, because theoretically nothing could come back. Then I'm going to say that int columns equals data.getMetadata.getColumn count. I need to know how many columns I'm working with again. And then a little bit differently, though, I'm using while data.next. So when we're talking about a result set, the result set is this huge pile of data, but we only have some of it at once. And we start off not at number 1, but before number 1. And so I use that while data.next, which says go to the next one, which happens in the first time, the first one, and then I can process that information as I go through. As you can see, I'm creating a vector of type string called row, which is a new vector of type string. And then for index is 0, index is less than columns, index plus plus, and I do row.add, and I'm forcing this to be a string because for this current purpose of this project, everything's a string, it's okay. Data.getObject plus index plus 1, again, making sure I don't go out of bounds. And so that means I'm fixed in width right here. I'm only going to go this many columns wide every single time. So even though it's a vector is a resizable thing, the vector itself is only one. It's only going to be a fixed size as we go through. Then after each row, I add that result to my table results, the vector of vectors, so it can hold all of them in. And I keep on going through that. And that .next will go through and read the result set. And then when it gets to the bottom of the current pile of the result set, it'll retrieve more data and process that as well. So this way I can have a huge mega query that has thousands and thousands of rows, but I only deal with a chunk at a time, and I have my memory managed more effectively. And again, because any one of those lines that are inside there that deal with the actual data, that can cause an exception for SQLException, we make sure we have a try-catch on that, and we handle SQLException right there. Once we've done processing that, we have our, right here, that results that we're working with. We use the fact this is a try with resources that is auto-closed at that point, and then processQuery is closed. And so that's the beginning basics of how we can actually use the data to actually go through and process a database connection. Again, if we take a look at all the stuff we did for that, we have all the methods we used to actually make that happen. That's all part of our database controller. Again, we had to make sure we use the jar file to add the driver to that, so we can add that to the project. And that's just done by going through and editing the basic structure of the project. But that's the beginning structure we have to do so we can get the connections to work with that. Check along with the next video so we can go further along with that and actually see how we can use this code right here to interact with a live database and show the information inside a GUI format. Thanks again, and have a great day.